I built this robot in 1 week so you don't have to. Basically, all this robot does is it balances itself. So when it's turned on, when it's placed downwards, it'll try to approach 0 degrees based on this gyroscope right tucked up there. And it does that by moving the motors in a certain pattern. And basically the goal of this project is just to teach students programming. So I'm a part of a club in college, AI and automation, where we basically just build systems like that and teach different control loops. So this one will use this PID to actually balance itself. And since I'm more mechanical focused, let's talk about the CAD and why I chose these parts. All right, so over here, if you can see that I have the battery, the Arduino Uno, the motor drivers, these bolts and nuts, the actual MPU, a 6050, which is the gyroscope, a TT motor, which are very cheap, they're like $1 each, and this wheel placeholder. So I'm using an Elegoo like smart car kit, I think it's called, and basically it's just a kit with a bunch of sensors and a chassis with 4 of these TT motors and 4 of these wheels. So what I'm actually doing here is I'm taking the accelerometer from that kit, the motor driver that comes with that kit, the Elegoo Uno R3, which is an Arduino that comes with that kit as well, and the battery that comes with it. And I'm just making it into something different. So over here is the CAD of the robot. So as you can see up here is just the motor driver that I showed over here before. Oh, did not mean to hide that. We have the motor driver that drives these 2 TT motors. We have the accelerometer, which is placed, the sensor that actually measures the pitch and yaw of the robot is directly in the center of gravity. The Elegoo Arduino is over here in the center as well. And the battery, which is like the most heavy portion of this robot, is dead center. So the center of gravity is like is just directly in the middle, which is great. The actual chassis is mirrored. So if you were to cut this perfectly in half here, it would be a perfect mirror on the other side, motor wise and wheel wise. So let's talk about the actual chassis. Since it is 3D printed, we have 2 parts. This is one piece. So like I said, all the actual electronics aside from the Arduino will slot up to here. And it's just very compact. It could print without any supports because this portion actually can be hidden. So it just prints like this right up here. And then we have this piece, which is the Arduino holder, which I lost the actual step file to for some reason, even though I CAD'd it in here. I think it was because I was switching between my computer and laptop. So I just got the version I 3D printed and put it in the CAD. So this goes here, and the nuts just slot in for everything. So it's all bolted together. Everything is very flush and compact. And it's probably one of the smallest balancing robots that you'll see. So stepping away from design, let's talk a little bit about programming. So basically a rundown of the code that I've used. So I have 3 versions of this code. One of them was just for the gyroscope. Basically all it did was as this robot would tilt in either this direction or that direction, it'll output values. And those values that were output by the accelerometer ended up being turned into the degrees that it actually moved. Now, speaking about motors, this is just a very simple code that I initially ran. It was just all the motors move forward at 100% power. Basically just to make sure that the driver was wired right, because initially it wasn't wired right. I had it because I thought this was just 5 volts. I had the 5 volt, the power coming in from the 5 volt battery plugged into the 5 volt port of the power supply. However, not power supply, of the driver. However, there wasn't enough current to drive out these motors. So I ended up moving it to the 12 volt port, which actually is not only for 12 volts, even though it says that. It also outputs more current than the 5 volt portion here. So it needs to be switched. And honestly, after that, I combined the 2 programs together, while also using stuff from like Stack Overflow, because there was some code on there that for a different self-balancing robot, because I didn't know how to set up the PID controller properly. So programming took like the most time. Like the whole CAD was done in about an hour because it's just simple stuff. I mean, you're slotting stuff together, and making sure like things don't overlap. But with the code, it was just really drawn out because you had to actively tune the PID controller just to make it work properly. And the working code is on my GitHub right now for all 3 things I described. So let's talk a little bit about wiring. I mean, it's quite hard to see, but we have basically the battery voltage, so power and ground, all daisy chained together from the Arduino to the motor driver. So the motor driver, it's 12 volt into the ground. And then on the Arduino, it's VIN, and ground for the battery. And then after that, we have the accelerometer wiring, not the accelerometer, the gyroscope wiring, to where it's SCL, SLA, or SAL, something like that, and then ground in the 5 volt from the Arduino. Then we have the motor driver, which is just standard wiring. Basically, it's all digital or PWM, but you have to make sure that the enable A and enable B are on the ports where there's like a little squiggly line, because that just represents, I'm pretty sure, just PWM. And the other just 4 wires can be any digital port. And now that it's basically, I explained everything, let's see it balance itself. So basically all it's doing is that it's trying to get to 0 degrees and it's jittering between those 2 angles until it stops. That means it's at 0. So we're going to be making a follow-up video, probably on YouTube Shorts, but basically I want to get the cost down of this robot to under $70. So the self-driving robot car kit is around $70, and the only parts that come from there that you can't buy normally is this battery and these wheels. So I just want to make 3D printed wheels and a separate battery holder with the switch, just so anyone could make it just from parts from Amazon. And thank you for watching, and hopefully you come back and see what this project turns into.